after Cannizzaro reaction. Let's start with formaldehyde. I have added dilute KOH and I'm asking you write the product. So write the product first and then listen any further. Get your products first. Now I hope you have got your product, and because I have given you dilute KOH, so you should get no product as your answer, because it doesn't have any alpha hydrogen, acidic hydrogen, so it cannot show aldol condensation. It can only show Cannizzaro reaction, and Cannizzaro reaction demands concentrated KOH, and what's given here is dilute KOH, so nothing going to happen. Now let me make it a concentrated KOH. Now there can be Cannizzaro reaction. Now retry and get your product this time. Now I assume you have made your product based on the problem we did in Cannizzaro reaction that we studied. Based upon that, we'll learn quickly how to write the product of Cannizzaro reaction. What's going to happen is OH minus is going to come and attack this carbon. From this carbon, one of the hydride is going to come out. When it comes out, let us do one more time, and this is the last time we will do step by step. Next time you have to learn to do it directly. When this OH minus attacks, this C double bond O turns into CO minus, you have OH. There are plenty of hydroxide ion present in the system, and any one of them will abstract hydrogen from here. So you have unstable tetrahedral intermediate like this, and now they are pushing from both the sides this carbon. So this carbon have to lose this hydride. When it loses hydride, it forms a double bond with one of the oxygen, and that's how you get carboxylate ion. So one of the product would be a carboxylate ion, and when that hydride goes and attack unreacted formaldehyde. That hydride comes here, attacks this carbon, and you have a bonding like this. And as I have told you before, this alkoxide will abstract hydrogen from the water molecule released into the system. So this is going to be a neutral alcohol. So this is going to be the product. So what you will do is, depending upon the structure of aldehyde, you will once oxidize this aldehyde to carboxylic acid, and once you will reduce this aldehyde to the alcohol. And that's how you are going to get the product of Cannizzaro reaction. So in this case, to write the product quickly, you just, based upon the structure given, you just oxidize it. This is formaldehyde, make it carboxylic acid of 1 carbon. I am assuming that we have done protonation. So instead of writing the carboxylate ion, we are directly writing the acid. This will be the acid one part. This is the oxidation, and when the reduction will occur from formaldehyde, you are going to get methanol, alcohol of 1 carbon, like this. So these will be the product of Cannizzaro reaction. And then suppose I have metachlorobenzaldehyde and I am carrying out Cannizzaro reaction. They will not tell you Cannizzaro reaction, they will write KOH concentrated. From this reagent you have to identify that this reaction is Cannizzaro reaction. So if this is a Cannizzaro reaction, then you just oxidize this aldehyde, assuming that we have done the protonation. So you have the acid, not the carboxylate ion. Rest of the structure will remain as it is, fine. And one of the compound will be the reduction of aldehyde into alcohol. So you have metachlorobenzyl alcohol, like this. Simple. So that's how Cannizzaro reaction will be worked out. Now there could be again intramolecular Cannizzaro reaction, as we have seen for aldol condensation. Suppose you have ethane 1,2-diol, and then we have added KOH, concentrated KOH onto this molecule. Then there are 2 aldehydic group present. Fine. Now one aldehydic group is oxidized and other aldehydic group is reduced. That's what happens in Cannizzaro reaction. If you look at the mechanism once again, when OH minus attacks one aldehyde, hydride leaves out of that aldehyde and goes and attack another aldehyde. Now, two aldehydic groups are present in the same molecule. So one of the aldehydic group would be attacked. That will release hydride ion, and that hydride ion is going to attack the aldehydic group present in the molecule itself. So one of the aldehyde is going to be oxidized, the one that will be attacked by the base, and the other aldehydic group is going to be reduced, the one that will be attacked by the hydride released by the other. Fine. So no need to write the mechanism. I am not writing the mechanism. I don't have a need to write the mechanism because you have learned it already. So I will write the product directly, assuming that you are smart enough to cope up. So this is what you are going to get. This is glycolate ion. This is glycolic acid, and this ion is glycolate ion. So this is what you are going to get if you have intramolecular Cannizzaro reaction. Fine. There could be other situations, there could be other problems. Let's solve one more problem based on intramolecular Cannizzaro reaction. Suppose we have a structure like this, and I have added conc KOH into it. Now begin. How would you start? Work it out, get your answer first very quickly. Get your answers and then listen to me. So you have conc KOH, and this concentrated base can act as a nucleophile. Now this is going to go and attack one of the, first of all, check if there is acidic hydrogen. Phenyl rings, the carbon in the phenyl ring don't have acidic hydrogen. That hydrogen is not acidic. We had this discussion before. This hydrogen is not acidic. We had this discussion before as well. So there is no acidic hydrogen. This is the first thing to identify. If there would have been acidic hydrogen, there would have been aldol condensation. We will not be looking for Cannizzaro reaction. Now once you have checked that there is no acidic hydrogen, go and look for Cannizzaro reaction. Then we have to start looking in the direction of Cannizzaro reaction. So for Cannizzaro reaction, this hydroxide ion will act as a nucleophile. There are two carbonyl groups. This hydroxide ion can go and attack on any one of them depending upon their need and their demand. Now one carbon that will cry in a louder pitch, that will be helped first by this hydroxide ion. And the carbon crying in the louder pitch will be the one that is more deficient of electron. Now this oxygen is del negative, this carbon is del positive, this oxygen is also del negative, this carbon is also del positive. But this carbon has a facility of resonance with this phenyl ring. And the electronic density from this phenyl ring will gush out and fill the orbital of this carbon to a certain extent and mitigate the deficiency on this carbon. This carbon has a lower pitch of crying because it is less deficient. This carbon, on the other hand, don't have any stabilization effect whatsoever. The hydrogen from the other side don't have any inductive effect. So there is no stabilization of electron deficiency on this carbon. So this carbon will be crying in a louder pitch. So which one will be helped first? This carbon, the one which is crying in a louder pitch.